Welcome to Massanutten Regional Library's annual Deyerle Program Series on local history, programs on local history and culture presented by local authorities in their fields. This fall, we've focused on topics in preservation and conservation in the Valley. The Deyerle Program Series on local history honors Dr. Henry Price Deyerle, a local physician, and his wife Mary, who was a nurse. As early collectors of antiques and artifacts produced in the Shenandoah Valley, the Deyerles were instrumental in raising awareness of and research into the valley's rich cultural history. In honor of their parents, the Deyerle children have supported Massanutten Regional Library for almost 20 years, and it is because of them that this lecture series is made possible. Tonight, our program is Voices in the Silence, using ground-penetrating radar to identify unmarked burials in antebellum African American graveyards. I will introduce our speaker in just a minute. This is our last program in the Deyerle series this fall, but remember, you can check out some of our previous programs on the MRL YouTube channel. Look for the adult programming playlist. Tonight's program will also be recorded and available to view next week, so tell a friend. In November, we turn from local history to the stars. On Thursday, November 18th, again at 7 p.m., Massanutten Regional Library will become your personal telescope to the universe and will virtually host Dr. Yao Lun Yang from the University of Virginia to talk about the importance of the James Webb Space Telescope. Webb is NASA's ambitious scientific endeavor to reveal the hidden universe to our eyes using infrared technology. Stars shrouded in clouds of dust, water in the atmosphere of other worlds, and light from the first galaxies ever formed. In particular, Dr. Yang will talk about how he will use Webb to study the history of organic matter all the way back to the time when a sun-like star was born. Scheduled for launch in December 2021, Webb will be the largest, most powerful, and complex space telescope ever built and launched into space. Again, this program will be presented live via Zoom, and you can pre-register by visiting mrlib.org and going to our events calendar. A few Zoom housekeeping tips. This is a webinar format, so attendees will remain muted. But as you think of questions during the program, please type them in the Q&A box at the bottom, and I will share them with our speaker during the Q&A portion of the program. And now let me introduce tonight's speaker. Dr. R. Shane McGary is an assistant professor of geophysics in the Department of Geology and Environmental Science at James Madison University. He received his BS in geophysics from Texas A&M University in 2007 and a PhD in geophysics from the Massachusetts Institute of Technology and Woods Hole Oceanographic Institution joint program in 2013. He is interested in a variety of geophysical research topics, applying electrical, electromagnetic, magnetic, and seismic techniques to investigate cave and karst settings, archaeological sites, and deep earth structures such as subduction zones and ancient volcanism. In addition, he develops computational models to explore problems in planetary science and has a deep interest in geoscience education. He was awarded the Goodman Faculty Award for Outstanding Teaching in 2020. And now, without further ado, I'm going to turn the program over to Shane.
All right, well, thank you very much for that introduction. And I'm going to go ahead and share my screen here and put a PowerPoint up and start with that. So Voices in the Silence, using ground penetrating radar to identify unmarked burials in antebellum African American graveyards. I was going to say a little bit about myself, but some of that's already been done. After a short career, I guess not too short, about 10 years as a submariner in the Navy, I got out and did my undergraduate work at Texas A&M University, getting a degree in geophysics, and followed on with my PhD in what's called the joint program between MIT and Woods Hole Oceanographic Institution, where I did my PhD work on some deep earth problems involving subduction using passive seismics and magnetotellurics. So here I'm imaging fluids that are coming up off of a subducting slab about 80 kilometers deep that rise up and form the magma chamber under Mount Rainier. After I graduated with my PhD, I spent a couple of years in a visiting position at the College of New Jersey in a physics position in the physics department, and then moved to James Madison in a tenure track position. When I first got to James Madison, I was tasked with a couple of things sort of up front. One part was we had a lot of wonderful near surface geophysical equipment that had not really been out in the field for a while. And my department head and others really wanted me to try to push that, and also to try to engage students in undergraduate research. So one of the first things that I did when I got there is I reached out to national parks and state parks and historical registry places and just kind of let them know who I was and the equipment that I had and some of the things that I would be able to do with those and to get students involved. And Kristen Lays from Belle Plantation reached out to me and said that she had some cemeteries that they would really like to use ground penetrating radar on to kind of figure out where the burials might be and if there were any burials that were unmarked in these cemeteries. There were 3 cemeteries that we worked on. 2 of them were white historical cemeteries, at the Bowman Cemetery and the Heights Cemetery. And then the other one was something that was sort of marked as a suspected slave cemetery. There were some field stones in place and some oral history that sort of suggested that enslaved persons had been buried there, but there was really no way to verify that. And as we started to do the work there and to kind of get a better understanding for how this works, or how this sort of portrays itself in different places, it became really clear that the cemeteries, the historical cemeteries for white people were very different than the cemeteries for enslaved persons. The white historical cemeteries were generally well preserved. You've got these nice brick walls, you've got these markers, everything is kind of orderly. Whereas the cemeteries for enslaved persons were often really only known through oral history. Sometimes their exact locations couldn't be ascertained. Other times you had some field stones in place to sort of support the idea that there were burials there. And then there's some other indications. Sometimes if you bury someone in a wooden casket, when the casket gives way to the years, you'll get a depression that sort of forms over that. And you'll see that we encountered that in some of our places as well. White historical cemeteries, the burials there are often supported by extensive documentation. They not only know the people that are there, but they know some things about their lives and what they did and what they accomplished. In the African American cemeteries, the documentation is scant. In fact, for a lot of the plantations and the places where they lived, the only records there were transactions. There were no records of who died there, where they were buried. And when you bury people in a field with just field stones, you also can't tell who's buried there, who's buried where. So whereas the white cemeteries have the engraved headstones that hold up more or less through time, and we can identify individual burials, the African American cemeteries tend to be, if you're lucky, you can find field stones or maybe just different flowers that are in one area of the plantation that aren't somewhere else that may indicate that burials took place there. And to make matters even more challenging, a lot of the African American cemeteries were cleared later for agriculture or raising livestock. And you'll see one of the cemeteries that we'll be looking at today had that happen to it back in the 1920s. So some of the things that we can look for that give us a little bit of insight and kind of help us with our survey are some patterns in the way that African American populations tended to bury the folks that were there. The burials were generally on the property of the plantation, so a little bit easier to find there, and generally not too far, usually less than a mile from the main plantation house. The burials were usually put into either clean rows or small groups. Sometimes you get a segregation between families or whatever, but this helps us sort of identify things as we go in with the ground penetrating radar. A lot of times you'll find them on hilltops and near water, and all the cemeteries that we're going to talk about were one or both of those two things. And they were often arranged such that the deceased's feet were pointed east. And there are a couple of different explanations for this. One is that it was a Christian practice and that they were adopting that. And the other was so that they could rise back up and walk east back home to Africa. And then the burials themselves generally took place in wooden coffins when wood was available. So if we're able to find the depressions that sort of form when those coffins give in, if those weren't available, then we would just see shroud burials. And those are a little bit more difficult to detect with the ground penetrating radar, especially 150 years later. But you'll see that we were able to have some pretty good success with that. talking a little bit about sort of the cemeteries that we'll be exploring today. All of them are in kind of northwestern Virginia. And you can see the locations here on the map. The first one, Belle Grove Plantation, and I'll only be talking about the African American cemetery there. And then we have Corhaven Graveyard in Middleton, and then James Madison's Montpelier, where we have two different sites that we explored, and I'll talk a little bit more about that. The stories that we're trying to get at are about the people that work in these places, but at the same time, it's becoming something in the geology community to also acknowledge land use going back even further. So we look back to the Native American populations that inhabited these lands as well, and acknowledge that they were there. So I want to talk a little bit about how ground penetrating radar works, and I am going to, well, I'll just start. So ground penetrating radar transmits an electromagnetic signal into the ground, and the electromagnetic signal that it sends is going to be of a specific frequency, and the frequencies for GPR range from about 10 to 2000 megahertz, so very quick cycles. If we look down on the spectrum here, that's going to fall between kind of the middle of AM radio waves and then up into microwaves. So it's a very sort of high frequency wave in terms of geophysics. Most of the other geophysical techniques we use are going to be up in these other regions where the frequencies are, so where the frequencies are not as high, sorry, down in the lower range. There is a trade-off. So we use a 400 megahertz antenna. We could have used anything kind of in between here, but there's a trade-off with ground penetrating radar. The higher the frequency that you use, the better resolution that you're going to get on small targets. But the trade-off is that you're not going to be able to see as deep as you can with something that's lower frequency. So based on sort of the depths that we expected our targets to be at, we used 400 megahertz radar, which is able to penetrate about 2 meters into the ground. So we knew that we would be able to get a pretty clear signal deeper than we would need to. And the size of the targets that we're looking for, the remains of burials, would be significant enough that we would be able to detect them. I am not going to get into the weeds here with the math at all, but the Maxwell's equations are the 4 equations that sort of describe how electrical fields and magnetic fields interact. And if we combine those with these 3 equations, which are called the constitutive equations, it completely constrains the properties of the electromagnetic field. So everything gets described. These equations over here, the constitutive equations, sort of relate different pieces of Maxwell's equations through these 3 material properties. So mu is magnetic permeability. With magnetic permeability, sometimes certain types of objects, when they're in a magnetic field, the magnetic fields within those objects kind of line up and add to the strength of the field, and we can detect that with a magnetometer. If you imagine sort of taking a paper clip and you put it against a magnet, all of the magnetic domains in the paperclip kind of line up so that when you take the paperclip away, you can actually pick up other paperclips with it because it's become magnetized itself. The second, the sigma, is conductivity. And conductivity is another thing that we use geophysics to constrain. And conductivity is really looking at free charge. So we're talking about electrons that are able to travel over fairly long distances. And then finally, this last equation gives us something called electric permittivity, which is what we're going to look for in ground penetrating radar. As I said before, ground penetrating radar is very high frequency, and that sort of makes it perfect for looking for changes in electric permittivity. I'm going to try to describe that just a little bit here. So a wave of electromagnetic radiation, any kind of light, looks something like this. You have a magnetic field that collapses and it creates an electric field. The electric field collapses and it creates a magnetic field. And so you wind up with electric fields that sort of go positive and negative, and so on. And when you have something that's really high frequency, that polarization changes very quickly. So what electric permittivity is really measuring is constrained charge. So charge that kind of varies when you have something at the atomic level. So if we have, say, a hydrogen atom that's got a proton that's positively charged in one place and an electron that's negatively charged on the other place, and we induce a field across it, the positive charge of the field is going to collect or attract the negative charge. It's going to attract the electron. So that electron is going to start spending more time over on the side with the positive field. The negative field, on the other hand, is going to kind of hold the proton side of it. And so we sort of are able to see what's going on with the energy at that level, at least when we're talking about millions and millions of atoms that are all essentially doing the same thing. And by having something that's very high frequency, we change the polarization. So the positive side flips to negative, negative side flips to positive, and the orientation of the atoms within sort of flip back and forth. And because of the high frequency, we're able to sort of separate out the constrained charge from the charge that would move a lot faster if we had something that was lower frequency, something that would travel a lot longer. So we're looking for objects that have electric permittivity that is different than the surrounding matrix. Because when that happens, when the signal reaches something with a different electric permittivity, that energy fractionates, it partitions, and some of the energy gets reflected back upwards where it can be detected by the receiver. If you imagine sort of looking down into a pond, the energy from the sunlight fractionates when it hits the surface of the pond. Some of that energy reflects off the surface and you're able to see your reflection in the surface of the pond. But some of the energy also penetrates the surface and goes down and bounces off the rocks at the bottom. So you're able to see those as well. And ground penetrating radar works the same way, just with different frequencies of electromagnetic radiation. So here we have kind of a cartoon that is trying to show how ground penetrating radar works. Inside the ground penetrating radar machine, we have a transmitter and a receiver that are sort of located right next to each other. The transmitter sends those signals down into the ground, and you can kind of see that here. And when it encounters something that has a different electric permittivity, some of that energy partitions, gets reflected back up to the receiver, and the receiver can detect it. And I'll show you a little bit more about what those signals look like in a bit. If we're following something like a plane reflector, so something that maybe is showing the difference between soil and bedrock, then what's going to happen is as we move the cart forward, we're going to continue to sort of bounce these reflectors. And you can see that we can start to get a sense for what the depth is. And that has to do with the travel time as it goes, as the electromagnetic wave goes down and then comes back up. We're actually able to measure that. But it's a little bit different when we're looking for a smaller target. The electromagnetic radiation that comes from the bottom of the GPR kind of comes out in a cone. And so it can detect things that are sort of out in front of it. But because the travel time for something that's out in front is going to be longer than for something that's straight down, we wind up forming kind of this hyperbolic anomaly, so this hyperbolic shape. So if we send the transmitter here, this line is a little bit longer. That corresponds to a little bit longer travel time, and it shows up as something that's a little bit deeper because it projects it as being straight down. Then as we get closer to being directly over the point reflector, that we kind of find a peak. When we're directly over it, we get our shortest travel time, and that actually is what's marking the true depth to the target that we're looking at. But it's able to, the energy partitions were able to make sense of both small objects and long planar objects as we sort of go through. So when we said when the signal reaches something with a different electric permittivity, the energy gets back up, and also mentioned that we can use the travel time to determine the depth to the object. That requires that we know something about the velocity of the electromagnetic radiation of that frequency that is in the soil, but there are ways to determine that. And the shape and contrast of the signal actually gives us more information about the target that we're looking at. So here you can see some examples. This was, I don't remember exactly where we collected this set, but you can see that these hyperbolic shapes show up. So we're looking at sort of smaller, smaller targets here. And we can look at sort of the width of them that tells us something about how long the object is. Here you can see this one is much sharper, so it implies a smaller object. Sometimes things get kind of muddled together, but we can still sort of pick out the individual peaks. We can look at the way that the contrast between the white and the black stripes as the energy partitions. The greater the contrast, the greater the difference in electric permittivity, and that can help us make interpretations. And sometimes we get something like this, which is really showing that the ground penetrating radar is sending a wave in here, but almost all of the energy is getting reflected, and then it bounces off the ground surface and goes back down, bounces on the ground surface and goes back down. And you can see that these marks are basically multiples of one another. And that's actually what we call that signal. It's multiples. It's something that's just bouncing off of the target and coming back up. We'll see that sometimes when we have a metal object, which just takes away a lot of the energy, or something that is kind of a hard pan, something that got cut out and hardened, and you can see it's reflecting off of that bottom surface and just sort of bouncing up and down. Some of the advantages of GPR, especially for work like this, it's non-invasive. When you're working in these cemeteries, you really don't want to do anything that disturbs anything. The cart just rolls over on wheels. It's completely non-invasive. We get some real-time imaging of the subsurface. So ground penetrating radar is unlike some other geophysical methods, and that you can actually look at the cart and sort of see what is going on a little bit. It's not as good as, you don't get imagery that's as sharp as you'll get with the processing, but it certainly can help you figure out, where something of interest might end, or finding an area, so assessing an area of interest that you want to look at a little bit closer. It's good for identifying both stratigraphy, so sort of layering, and also structures or features or targets within the subsurface. It's pretty quick and efficient to deploy, which also helps you assess an area of interest. You can cover a very large area to figure out where the smaller area is. So when you're looking for cemeteries, you don't maybe know exactly where they are. You can run a quick survey that'll help you locate the boundaries of the cemetery, and then do a more thorough survey within that area. And it has a broad range of different applications, but we're really only going to be talking about one today. So the data collection, we used a GSSI 400 megahertz ground penetrating radar. It's treated us quite well. This is my student who is the primary student for this project. I'll talk about her a little more at the end, but Michelle Prue. And as you can see, we collected data regardless of the weather. This particular day, we had some episodes where our raincoats got soaked through, and of course, that's always a lot of fun to do that. The data collection strategies. One of the things that we understood was what our targets were generally going to look like. It's a little bit dependent on what the burials look like. The concrete casket burial is really only something that we saw in the white cemeteries. In the African American cemeteries, we were looking mostly for wooden caskets, which could sometimes be identified with a little bit of a depression over it, or the shroud burials. And we were able to ascertain pretty quickly for each cemetery how deep the shroud burials were. And we wound up doing a correction on this. The shroud burials were about 0.6 or 0.7 meters down. So 0.6 or 0.7 meters down. So about 2 feet down to the top of the burial. And because of another strategy we employed, I'll talk about in a minute, we were looking for something that was only about a meter wide. So we're trying to run perpendicular to the burials. And part of the reason for that is because we sort of understood that if we had a spacing between our GPR lines of about half a meter, then any burial, or at least any adult burial, and we had some burials that we suspect probably weren't, but when any adult burial is going to show up, at least potentially, on 3 consecutive lines. And if we were able to see something on 3 consecutive lines and get some other sort of supporting feature like a depression or a field stone that was in place with that, then we would feel pretty confident that there was a burial in that position. Some of the other things that we sort of had to deal with and figure out how to understand how they look differently than a burial would be going by a tree, the root system that kind of comes down, trying to figure out how does a root system look different from a burial. We had a couple of places where there was serious gopher damage, and we had to try to figure out what a gopher hole looks like relative to some of this other stuff. Some of the sites were heavily vegetated, so we had to really kind of work our way around that, and sometimes we weren't able to collect all of the data that we would have liked to. Another thing that, and I shouldn't say we did, Michelle did all of this, was we collected some soil samples. So we took a core that went a little bit down, generally outside of the place where any burials were, and we tested it with the ground penetrating radar to make sure there were no targets there. And she took the soil back to be analyzed on a machine that does particle size analysis. So depending on what your particle size is in a soil, tells you how you can kind of classify the soils. And all of our sites were basically silty clay loams or silty loams. And that tells us something about the velocity of ground penetrating radar in that soil. So we were able to kind of look that up and make the adjustment, which then sort of changes our depth constraints. But soil sampling is an important part of ground penetrating radar. The processing software that we used, I'm not going to spend any time looking at this. It was Radan 7 processing software. A lot of the processing techniques come from seismology, but they're really not as robust with ground penetrating radar. And one of the things that is sort of understood among practitioners of GPR is that if you can't see something in the original data and you only see it after you process it, you should be really suspicious about it. So the processing that we did was pretty minimal. We never talk about anything that we weren't able to see in the original data. We sometimes tried to clean it up to get a better idea of what exactly we were looking at, but we were really careful not to process anything too heavily. Talk a little bit about some of the sites that we worked at. The first one, as I mentioned, was Belle Plantation. Belle Plantation had an oral history that suggested there was a cemetery there and that the enslaved people at Belle were buried here. And there were field stones that were sort of scattered about inside this fenced off enclosure. And you can see here that although there's been some movement of the field stones, a little bit of shifting, that the burials could pretty much be identified to be in 3 rows. There were no depressions that we found here, which made us suspect that we were probably looking at shroud burials. Shroud burials that are 150 or 160 years in the past can be really difficult to detect. It depends on soil conditions. It depends on what's kind of happened with how the water goes into the ground and how it drains and all of those things. We also had a couple of trees that were in the area, and I'm not sure that this photograph corresponds with exactly what we saw there, but there were some trees and then there were some other scattered tree stumps. So we sort of had to think about roots and other systems like that. Here's a photograph of it where you can see the kind of the big tree in the corner there, and there's a smaller tree, and I think there's another one out of the picture to the right. So the ground penetrating radar lines that we took, these are the lines here. So we would take the cart, we'd start it here, turn it on, collect the line of data, shut it off, and then come back to the first spot again and do it again. You can see some of the lines are cut off by stumps. So we had to kind of work around things, or by trees. And we also we made sure that none of our ground penetrating radar work ever moved or dislodged any of these field stones. So the next cemetery that we worked at was Corhaven Graveyard. And Corhaven Graveyard was a little bit different. There were scattered headstones and footstones there. There were 2 that were initially engraved, although the engravings were unreadable from our perspective, just looking at it. I'm sure that with the forensic analysis or something like that, someone would be able to pull more out of it. This was highly forested. It is on a little bit of a hilltop heading down to a creek. So very much what we would have expected. And you can see here the lines of data that we collected. And this orange area down here, we didn't get much out here because this was really extensive gopher damage and really difficult to try to separate out. There were several depressions in here, and they're not marked, but you'll see them when we look at the results and interpretation. But there are some depressions in there, which is another part of the reason why they thought that there were burials here. This was actually a cemetery that was discovered by landowners, I want to say in the early 2000s, and they spent a lot of time trying to figure out what they should do with it. And in the end, what they decided to do when they brought us in is they created sort of a little bit of a display here where people can come visit the cemetery. The names of the people who were known to have been enslaved at the plantation that was there. It's usually just first names, but those names are available. And actually a poster that we made of the work that we did there is on display in a stand here as well. And we attended a ceremony when they dedicated the graveyard. And it was really an interesting experience from a community standpoint. There were about 150 people that showed up. We had lunch together and sort of talked about the importance of doing these things from a community perspective. The third place that we went to was Montpelier. And as I mentioned, there were two cemeteries that are there. The first one, there's sort of an image down here of what it looks like. There's a small display here, and then the burials are kind of in this wooded area. So again, really heavily wooded. These burials were in wooden caskets, so we were able to see depressions. There were scattered field stones, so it was really nothing engraved, but headstones and footstones that were kind of scattered. A lot of big trees, a lot of small things that aren't marked on here. These purple ovals are depressions, and we were pretty sure that they were telling us something about the burials. They were lined up east to west, so we suspected that they corresponded to burials. And then we collected the lines, of course, perpendicularly, and you can see that we get at least 3 lines over any burial that would be associated with a specific depression. The field Montpelier was a little bit more challenging in some ways because there were no surface expressions whatsoever. The area is quite large. Each of these blocks is 20 meters by 20 meters. And the field had been used in the 1920s when the DuPonts owned James Madison's Montpelier. They used it as an agricultural area and also for livestock grazing. The oral history from here actually didn't predate the DuPont's time. There was a story that was told that kind of got passed down about a skull that was found by one of the children. I don't know if it was a DuPont child or somebody else who was visiting there, but they found a human skull in this field, and they were using it to kind of play with, and probably not the most respectful way to use a skull, but at the same time, because of that, and because of sort of the story that came out of doing that, the lead archaeologist there, Matt Reeves, had a hunch that there might be more burials in that side of things that might have been connected to the other spot over here. There is a hill that kind of rides up in this area over here, and as you'll see in a little bit, that is where we found a number of burials. Since we have turned our report in to the lead archaeologist there, they were using this area was part of an enclosure for horses that were grazing. But since then, they've moved the fence backwards and they're leaving this area pristine. One of the other things that I'll mention now, I guess, is that the archaeology team at Montpelier and the people that run Montpelier have gotten into contact with a significant number of descendants of the people who've been enslaved there, and given them the ability to sort of make determinations about anything that happens in these areas and to sort of help to manage those areas. So kind of getting into the results now and talking about what we were able to see as we went through these burials. So we would take a line, and I was kind of showing here. So this line is 60 meters long, and the lines are running north-south as always, because we're trying to run perpendicular to the burials. And so for each one of those lines, what we would have to do is sort of, so this is a 10-meter line here, but that line would go 60 meters. We sort of go through and look at everything, and we start to mark any features of interest. And we sort of develop kind of a code to do that. And when you look at Montpelier, what we did with that is each of those lines we would analyze basically by hand. We'd do our processing, analyze by hand, mark something that would tell us how deep the signal that we were getting was, what shape it was, what sort of pattern that it fell into. And then we were able to start to look at places where 3 lines in a row were showing a burial, for example. And these 3 burials here were really interesting because not only did we find the 3 lines in a row that were consistent with a burial, but there was another one on the west end. So remember, the feet would be facing east on the west end that indicated a field stone was actually buried at the same depth as the burial at that point. So there's a lot of painstaking work that goes into this. And again, I have to give at least half of the credit for that to my students who spent a lot of time, especially Michelle, working with this data. So in order to try to come up with some way to determine how likely something was, or a person was buried in a specific location, we developed a set of criteria. If we found radar signals consistent with burials on the 3 consecutive lines at the proper depth, at the proper orientation, and either a surface expression such as a headstone or footstone that was associated with the burial, or the sharp radar signal that we talked about on a 4th consecutive line, or something like a depression at that site, we would call that burial highly probable. So basically, we needed 4 pieces of evidence in order to try to make that claim. The next step down was a probable burial, and a probable burial was basically just missing one of those things. So you would get radar signals on 2 of 3 consecutive lines at the proper depth, at close to the proper orientation, along with a surface expression, or without a surface expression, if we could get the radar signals on 3 consecutive lines. There were a couple of places where we got 2 radar signals with a field stone, and our suspicion in some of those cases, it's hard to tell if we just weren't able to pick something up for the 3rd one, but it's also possible that it was just a child burial or somebody who was a little bit smaller. And this is, again, one of those questions that we're not going to get the answer to without without doing some kind of excavation. And then finally, anomalies that were classified as possible. They either were radar signals on 2 of the 3 lines, or there was 1 radar signal with some other pretty clear sign that there was someone buried there. Generally, we would be talking about the depression. We did not show any burials as confirmed in sort of the work that we do. Confirmed burial is something that requires actually exhumation and finding the remains specifically. So I'll talk a little bit about the results that we got from this. At Belle Plantation, you can see the map here. The trees and the stumps are in place, and you can also see the field stones. And we were able to find some burials that actually lined up really well with the field stones down in this corner and up here. There were other areas where we found burials that we suspect, and you can see this has a lower classification on it because we didn't find any surface expression to go along with it. But we found some other burials over on this side. But as we move over to let's see, this is going to be east over here. So as we go over to the south side of the site, we have these field stones, but we weren't able to detect any reflections. And our suspicion is that there are burials there. It's almost always the case when you do a ground penetrating radar survey that there are more burials than you're able to detect. And that becomes even more true when so much time has elapsed in between. But what we see here is that we weren't able to detect any burials here, but we suspect that they were there, and that what happened was either the drainage patterns on the land or something else just made it so that these burials were not detectable. But we were quite certain about many of the burials. You can see there are a number of highly probable burials here. And just like we did at Corhaven, we made a poster that sort of explained our results, explained our methodology, and that's hanging at the little museum inside Belle Grove Plantation. So a big part of what we're trying to do is to give a voice to those voices in the silence, to do what we can just to make sure that their existence, their contributions are acknowledged, and that when we look back through the history, that we're treating them with the respect and the dignity that maybe was elusive to them during their lifetimes. So our compiled results at Belle Grove, we had 8 highly probable burials, 7 probable, and 13 possible that we were able to locate. Moving on now to Corhaven. This one was actually very difficult to get good results, and a lot of that has to do with just the large amount of vegetation that was going on. The places where there are depressions, we actually weren't able to locate anything really inside the depressions. A lot of them had stumps and trees and things growing up, so we couldn't even get the ground penetrating radar in there. We were able to find some burials outside of that, and there wasn't much doubt that this was a cemetery to begin with. Like I said, there were a couple of stones that were engraved, even though they were no longer legible. And you can see that we were able to locate some burials within this. We did have to spend a lot of time trying to separate roots from burials. Roots have a tendency, if you find them on 3 consecutive lines, they have a tendency to not be the same size, and they also have a tendency to not be at the same elevation. So we can kind of go through when we're making our markings, and we also know where the trees and stumps were located. We're able to sort of extrapolate from that we're probably looking at a root here, and we wouldn't count that as a reflection that would potentially be a burial. So at the Corhaven graveyard, we didn't find any highly probable burials because we weren't able to correlate anything with a surface feature. We did find 5 probable burials and 7 other possible burials. Moving on to James Madison's Montpelier, this is the cemetery that was recognized to be a cemetery. You can see the depressions that are in place here, and we were able to find a number of reflections or hyperbola within those depressions. We were able to move the GPR cart through. Again, we were dealing with really thick vegetation, but we managed to get some pretty clean results here. And we were able to identify at least some very highly probable burials, and then a number of other burials that we acknowledged were probably less certain. In the recognized field, we got 4 highly probable burials, 19 probable, and 25 possible. So there were actually more burials there that we were able to detect than the archaeology team thought were probably there. So we sort of expanded on what was expected there. And then the field Montpelier site, this one was actually really interesting. Like I said, there's a hill that kind of runs up in this area. We kind of come down slope into here. The ground penetrating radar, I guess before I get to the burials, mention some of the other things that we were able to find. We found some sort of rock falls that were down at sort of the bottom of the hill. And we also found signs that there was a relic stream that once ran through this area. And of course, that supports again, the idea of the African American burials on a hilltop next to a source of running water, even though that source of running water either isn't there anymore or it's another sort of 200 meters to the side. There is another creek that sort of runs down there. It's hard to tell if that was the same creek or a different creek, but the evidence showed that there was a creek that ran down towards the bottom of this hill. And this is the place where we were able to really get some clean indications of burials there. A number of these were things where we were able to find a headstone, or in one case, a footstone, and the three pretty clear readings. I guess I'll go through the numbers a little bit here too. There's also a pipe that was installed down here that fortunately didn't go through that. I don't know if anybody was thinking about that. Nobody seems to know what this pipe does, but we were able to locate it pretty cleanly in the ground penetrating radar. And it also gave us an opportunity when the descendants came out to watch us work and to talk to us. We were able to let them use the ground penetrating radar and sort of pushing it over if they wanted to, and letting them know that the target that they would be finding was a pipe. And so they could push the GPR over the pipe, and the signature of the pipe would come up really clearly. And it wound up leading to a really nice conversation with Michelle and I, and with the descendants from the people who had been enslaved at Montpelier. So at the Field Montpelier site, despite the fact that there were no surface expressions, we were able to identify 8 highly probable burial sites, 26 probable and 6 possible. And if we sort of add all of those up and look at that, we had 128 burials of some sort that we were able to say are at least possible or probable to be at that location. And in the case of Corhaven and recognized Montpelier, we were able to confirm that those were indeed cemeteries. And I think our evidence at Belle Grove, in addition with the oral history, and at Field Montpelier, just kind of the strength of what we were able to see, confirm that those are also cemeteries that contained the burials of enslaved persons. And it just occurred to me that I don't have any way to tell time, so hopefully we're in a pretty good place here. This is an image from James Madison's Montpelier at the field site, and you can see it's really just grass over here. And this is a group of the descendants. So this is my student Michelle pushing ground penetrating radar. I'm trying to explain a little bit about how it works, and then kind of interacting with them and letting them take a look at the ground penetrating radar. And this is just a picture that was taken for the JMU Madison magazine. So again, my student Michelle and myself, I didn't always have long hair. This is kind of a pandemic hair. We also were written up in the Washington Post for some of the work that we had done, and we're working on publishing a paper that shows our results. I guess I should talk a little bit about Michelle. She went on from this project to get her master's degree at University of Kansas, where she did her master's thesis was in humanitarian or archaeological geophysics. She used ground penetrating radar to try to successfully find Pleistocene rhinoceros at a site in Nebraska. So she used the GPR to kind of find that. And she just started this last fall as a visiting scientist with the FBI at Quantico as part of their clandestine burial team. So she's kind of taken the work that we did together and turned it into something that it looks like she's going to make a career out of. I do want to thank Michelle. She was the lead student for the project. Reagan Cronin and Donovan Bavarni. Reagan was another student of mine who helped do the data collection while we were at Belle Grove. She's now finishing up her PhD at the University of Colorado at Boulder. Donovan Varney helped us with the data collection at Corhaven, and he is now working with a geotechnical firm in Charlottesville. Kristen Lays, who was the administrator at Belle Grove that first contacted me and gave us access to Belle Grove. Sarah Coors, who was the person that we had contact with at Corhaven Graveyard. She's also the person that did all of the work for the dedication. I'm sure she didn't do all the work, but she was the person that was in charge of doing the work to put together the dedication ceremony and to make it kind of a destination site and a place where dignity and respect are very clearly important. And then at James Madison's Montpelier, we had Dr. Matt Reeves and Dennis Bjorklund, members, the head of and a member of the archaeology team, to give us access to those sites there. And we also want to thank the group of people that were descended from those enslaved at James Madison's Montpelier for their support, for their good wishes. It was really encouraging to be able to get the sense of how much they appreciated the fact that we were there and what we were doing. So this is just an image of a reunion of some of my students at a conference a couple of years ago, but hopefully I didn't run too short or too long. I actually have no idea, but at this time I will take questions.
No, you're 7:51, so you're perfect.
I have some experience, but I don't have a clock.
Yeah, that was really good. We got a couple of questions already. So the first one, and you may have kind of touched on this, but Belle Grove enslaved 276 souls. Have you used the ground penetrating radar in another site on the grounds? The map you showed this evening indicates a smaller size burial ground.
Yeah, it really is a smaller size. I don't know. So a lot of times the people that were enslaved sort of in the plantation house would get buried very close to the plantation house. And if there was another group that worked in fields or whatever, they were sometimes buried elsewhere. I don't think that there's any evidence that suggests, the evidence clearly suggests that there are more burials there somewhere, but there's no evidence that gives us any indication of where that might be.
Okay.
The land for Belle Grove was actually quite a bit larger, I think, than it is now. So we may never recover that.
Okay. And this is a local question. There's an unmarked section in a church cemetery in the Broadway area that is believed to have African Americans, perhaps enslaved people, buried there. Do you have any advice on how to properly acknowledge and protect the grave sites?
Yeah, I think my expertise, I have done a fair amount of sort of learning about what's going on there. There's a really good book by a professor. Her name's Lynn Rainville, and she's written a book on enslaved burials in Virginia, and that would be a good place to start.
We have it.
That's it.
This is the book. I just said it. Yeah. So yeah,
history's great. Yeah, it's a fantastic book. Sarah Coors is somebody who really did that. She got a community together, and I think what she's done at Corhaven is just spectacular. And it might be worth just going there, looking at what they've done and trying to get a sense for that. You really, I walk away from that when I go there, just really feeling, I guess the love that Sarah put in to try to make that right. And I think that's a really good or a really good project to kind of emulate. That's not really where my expertise is. I don't want to lay out too much there.
Do you have any projects on the horizon that you're working on in this area?
We did actually work on one up by Winchester just last Wednesday. And we also did some more work at Quantico. The cemetery in, it's near Winchester. I forget exactly what town it was in, but the kind of a sad story, but it's at a church, and there was a white cemetery and a black cemetery. The white cemetery, of course, had all the things that we talked about at the beginning, better maintained, better records, all that stuff. But apparently about 30 years ago, the church decided that they needed to expand their parking lot, and they bulldozed all of the stones in the African American side of the
Oh my goodness.
and extended the parking lot over some of that. And a lot of the people that are at the church now, even though a couple of the folks that were involved in this, in the renovation, are still there, they reached out to me and they wanted to try to repair this.
Mm-hmm.
And we actually haven't processed those results yet. I have a new student, Emily, who's doing the work on that. And part of why we took this on was to help answer their questions, but also to give Emily some experience on equipment. We're doing some archaeological work that is late Stone Age and early Bronze Age. So it has nothing to do with cemeteries, but about 40 kilometers northeast of Athens over Thanksgiving break in Greece. I wanted her to get familiar with how to collect the data, how to process the data. I do get a fair number of requests to work on things like this. I really don't have much interest in working on the historical white cemeteries. The African American cemeteries, especially those containing enslaved populations, are something that I'm happy to do when I have students that can benefit from it.
Well, I think that answers the many of the questions that just came in about how to gain access to your students and your ground penetrating radar. So if you're comfortable, I'll put in your email and let these individuals contact you. They may have unmarked graves in a local cemetery, which may be Linville Creek Church of the Brethren, might be what they were talking about. And then the couple in Stanton. And have you ever done
No,
any private burial grounds?
No, I don't.
Okay.
I don't think that we
All
have. Well, I guess Corhaven kind of is.
Yeah. I guess it was on
It's
private
privately
property.
Yeah.
Yeah. Okay. So
But they were going so far over the top with, just doing the right thing. Really felt more organized.
Yeah. So with Corhaven, that was private property that individuals who own that opened up, and it's now you can access that. Like the public can now go to that.
Yes.
Correct. Okay.
Yes. And are encouraged to. Yes.
Good. Yeah, we put the website for that in there because that's the one that was least known to us, and I'm thinking our public too. So let's see. All right. Any other questions out there in TV land? So you currently only have one student. Are you hoping to get more students?
I am. And usually I have somewhere between 4 and 8. And this has been kind of a tough semester, just load wise. So I haven't really pushed to try to bring in more, but I will start again in the spring to try to bring in more students. And this is one, as you mentioned, sort of in the introduction, I do a lot of different kinds of work. So the students that come to me are interested in doing a lot of different things. Noah here did magnetics with me, trying to constrain Mole Hill into how we're looking at we're trying to locate the source of the hot springs in Bath and Highland counties, or in Bath County particularly. That project actually got shut down by COVID. Did a project where she wanted to learn about impact cratering on Venus. And so we sat down and over the course of about an hour, we developed a project for her that she's actually turning into the first chapter of her PhD thesis at University of North Carolina. So I get doing a wide variety of different things, but I'm sure that I'll have students come through that are really interested in African American cemetery work.
Okay. Well, wonderful. All right. It's just about 8 o'clock. So any other questions out there? Let's see. Was this your first, like when you got here, was this the first time you did this kind of archaeological work with burial grounds?
Not exactly.
Uh-oh.
It almost is. When I was at the College of New Jersey, I was responsible for teaching the upper level electromagnetic physics courses for the geology course, because there was no geology department there. In the sort of the advanced geology course, we had a ground penetrating radar unit that we were able to borrow from the New Jersey Geological Survey. And so I took the class to a normal cemetery there just so that they could kind of play with it and show the detection of burial. So that was part of what gave me the idea that this was something we could do when I got to JMU.
Okay, wonderful. Okay, all right. Any other questions? I'm just gonna one more last time. All right, we put Shane's contact information in there, of course, and there's a couple other resources along with the Hidden History by Lynn Rainville that MRL has. So, and again, this will be recorded. So if you missed something, if you want to go back and watch it again, it'll be on our YouTube channel come early next week. So I want to thank you, Shane, for sharing all of this with us. This was so interesting and important, and I followed all the science, so I'm feeling good about myself right now. So this is good.
Excellent. That's good to hear.
Yes, well, you're a good teacher. So there you go. All right. Well, thank you everybody for coming this evening. And again, remember November 18th, we have another program about the Webb Space Telescope. So join us then and have a great evening.